Okay, so our next video is going to help us do some more practice with finding the nth term. So we left off with being able to write things recursively in that 11.2 video, and we talked about the general or explicit rule, but it was a little bit more difficult to find. So today we're going to build on that concept a little bit more, and we're going to use some strategies to help us recognize patterns that we see within a sequence and help us find a general rule or the nth term of a sequence. Sometimes it'll ask for it recursively, sometimes it will ask for a general rule. Remember, recursively depends on the previous term, and explicit just depends on the value of n. So you have some strategies listed in your notes. You might want to put a big star by them. It says finding the nth term strategies. So look for a common difference, which means are you adding or subtracting the same number between every term? Look for a common ratio, which means are you multiplying by the same number for every term? Keep in mind that you could be multiplying by, let's say, a half, which is tricky because it looks like you're dividing by 2, but really we would say you're multiplying by 1/2. Likewise, when you're subtracting, you're really just adding by a negative, but that's okay. If you have numerators and denominators in a fraction, look at those separately. Okay, so consider a pattern for the numerator, and then maybe a different pattern for the denominator. They don't have to be the same pattern happening. Finally, if your signs alternate, so if you have one term that's negative, and then one that's positive, and then something negative, and then positive, you're going to need to use -1 to either the n power, okay, and that's going to put these in the odds, or you'll need -1 to the n plus 1 power, and that's going to put things most likely in the evens, assuming we're starting with n equals 1. Because if n equals 1, and you take -1 to the first, you get a negative answer, and then to the third, to the fifth, to the seventh, to the ninth, you're going to get negatives in all of your odd places. Whereas if n is 1, and you do n plus 1, then you get -1 to the second, and then you've got all of your negatives will appear in the even places. But we'll look at that, don't worry. Alright, so find the nth term of the following sequence. So we're looking for some rules that will help us to define our sequence. Well, we know that this is n equals 1, 2, 3, 4, 5. So recursively, remember you need to start with knowing one of the terms. So we'll say that a sub 1 is equal to 4. That we've got happening. What's going on between each one of these terms? Hopefully in your head, you said that you were adding 1 every time. So that means that a sub n plus 1, our next term, is going to be take the previous term, or the starting term, okay, and add 1 every time. Okay. A sub 5, which would be this one right here, is equal to a sub 4 plus 1. 7 plus 1. So it works. Now, explicitly gets a little bit trickier. So we just want to have a sub n. We know that our difference, what we're adding every time, is 1. But I'm not starting with 1, I'm starting with 4. So how do 4 and 1 relate to each other? Well, there's a difference there of 3. How do 5 and 2 relate to each other? There's a difference there of 3. 6 and 3, difference of 3. 7 and 4, difference of 3. 8 and 5, difference of 3. So in comparison with our n term, we are adding 3 every time. Okay, remember a sub n is just how do these numbers, this sequence, how do they relate to this up here? Versus recursively says how does this number relate to that number? And how does this number relate to that number? Alright, find the nth term of the following sequence. So again, let's start with n equals 1, 2, 3, 4, 5. Recursively is going to be the easier one. So we know our starting term is equal to 1. This time we're going to add 2, and add 2, and add 2. Which means that each term says take the previous term and add 2. Done. Explicitly, okay, we've got to think to ourselves, how does this relate to this? And how does this relate to this? And how does this relate to this? Okay? Well, this has a difference of 0, difference of 1, difference of 2, difference of 3, difference of 4, so not quite as straightforward as the last one. Thinking about a pattern for a sub n, okay? This one we have a twice each time, right? Well, 2 times 1 is 2, minus 1 is 1. 2 times 2 is 4, minus 1 is 3. 3 times 2 is 6, minus 1 is 5. So it looks like we're taking twice our n value and then subtracting 1. Again, you're looking for patterns for how do these numbers relate to these numbers. Okay? So if I take 2 times 5, that's going to be 10, minus 1 is 9. 2 times 4 is 8, minus 1 is 7. Okay? Try to think about that a little bit, justify that in your head for how we got that formula. Alright, find the nth term of the following sequence. This one we're not going to do recursively, we're just going to talk explicitly. So n being equal to 1, 2, 3, 4, 5. What is 1 in relation to 1? 2 to 4, 3 to 9, 4 to 16, 5 to 25. Hopefully you are seeing that as a pattern of n squared. Right? You're taking your n value, your input, and you are squaring it to get the value of a term in a sequence. Alright, find the nth term of this sequence. So we again want to start with n. 1, 2, 3, 4. Alright, well, what's happening here? How does 1 relate to negative 5? How does 2 relate to 10, 3 to negative 15, 4 to 20? This one we talked about a strategy at the beginning. We've got a negative sign, then a positive sign, then a negative sign, then a positive sign. So our formula, a sub n, is going to have a negative 1, and we want it to fall in all of the odd terms, right? The first term, the third term, the fifth term will be negative, the seventh term will be negative. So if we just take negative 1 to the n, that means anytime you put in an odd number, you're going to get a negative sign. Okay, so that takes care of all of our negatives. How does 1 relate to 5, 2 to 10, 3 to 15, 4 to 20? What are we doing every time? Hopefully you told yourself that you are taking 5 times the n value. And that's your final general term. Okay, find the nth term of this sequence. So again, start by setting up your n's. We are alternating again, positive, negative, positive, negative. So, for our formula, we're going to need something with this negative 1. This time, though, I don't want the negative signs in the odd ones. I want to have the negative signs in the even locations. So I don't want to raise it to the n, because if I do that, then negative 1 to the second gives me a positive 5. So that's not going to work. What I do want to use then is n plus 1. That's going to put a negative sign in every even location. Okay, so that takes care of our negatives. Now let's think about our relationship between 1 to 2, 2 to 5, 3 to 10, 4 to 17. There's no good pattern as far as adding, subtracting, or even multiplying. We know we've taken care of the negatives already. I'm going to say that 2 squared is close to 5, but that's 4. 3 squared is close to 10, but that's 9. 4 squared is close to 17, but that's 16. Each one of these terms is going to be our squared n value plus 1 more. 1 squared is 1 plus 1 is 2. 2 squared is 4 plus 1 is 5. 3 squared plus 1 is 9 plus 1 is 10. Did I say that right? 4 squared plus 1 is 16 plus 1, which is 17. And then again, our negative sign is being taken care of by all are alternating -1 to the n plus 1. Alright, this time we have our fractions. And in your hints, we said look for a pattern in the numerator, then a pattern in the denominator. Okay, so we're going to think about this as two separate pieces. We need to find a pattern in the numerator and then a pattern in the denominator. Well, a pattern in the denominator I think is easier to see. 3 and 1, 9 and 2, 27 and 3, 81 and 4. What are you doing every time in this denominator? Hopefully you notice that you are multiplying by 3. This is 3 to the first. This is 3 to the second, 3 to the third, 3 to the fourth. So the bottom is just going to be 3 to the nth power. In the numerator, you're multiplying by 2 every time. Okay? So we want to have a base of 2 for exponential, right? Repeated multiplication turns into exponential. But this is not 2 to the first. This is not 2 to the second. This is not 2 to the third. This is not 2 to the fourth. This one is 2 to the third. This one is 2 to the second. This one is 2 to the first. This one is 2 to the 0. So that means that at any one term, I'm taking 2 to the n minus 1 power. We said we wanted this one to be 2 to the 0. Well, that would be n minus 1. We want this one to be 2 to the first. Well, that would be 2 minus 1. This one we wanted it to be to the second. Well, that's 3 minus 1. 4 minus 1 gives us the third, so that's 8. Now again, these take time. You've got to justify some things in your head, and you can test them then by plugging in your values. So, if I plugged in 3, I would get 2 to the 3 minus 1 over 3 to the third. Well, that's 2 to the second, which is 4 over 27. And that is, in fact, the value of my third term. Okay, lots of practice. So again, strategies, put a big star by these in your notes. Okay, if signs alternate, keep in mind -1 to the n will usually result in negatives in the odd location. -1 to the n plus 1 will give you your negatives in the even location. All right, time to practice.